Hi everybody. Welcome to the intro for XFC 2026. A bit of a shortened time frame this year for both XFC and Wiki, but I'm going to go over the details for the competition and what you need to do in order to submit agents, the requirements that they have, and also the format of the final competition, including the live stream. So the overall competition format is there will be a submission on June 10th for your agent, your final agent submission. This is also what we call qualifying. The reason for this is because I use the time from this point up to the competition for both integration and testing of the agents to make sure that they operate correctly. And also I evaluate them against a very simple baseline agent in order to determine seeding. The reason we need to do seeding is because the final competition itself is a playoff. It is a single elimination bracket format playoff, and so we have seeding and buys. The seeding, like I mentioned, is determined by that evaluation against a simple baseline agent, and buys are assigned just based on need, depending on how many teams submit and the single elimination bracket structure. So that will be determined once we know how many teams are submitting agents. It also affects some other things that we'll talk about, including the live stream the day of the competition, including the presentations, because we do require that students make a presentation detailing their agent and the methods they used. This live stream, the details are to be determined. We've used a couple different options in the past, including both YouTube live streams and Twitch. So we haven't decided which we'll use, but it will almost definitely be YouTube, at least YouTube. We may do multiple, but we've had success using YouTube in the past, and the intent is to have it be a high fidelity stream and potentially also be able to talk to teams during the competition itself, so we can discuss what they did. We've had some issues there, so I'll be trying to work that out. But just so you know, the only thing that you need to do as a team is make sure that you have a spokesperson that will respond if I am asking something about, like, oh, why do you think your agent did this during this part of the competition, or in this particular scenario we saw it do something that we didn't expect. Why do you think that is? So I'll make sure that everybody has all the details they need for the live stream beforehand, but that's the only thing that you need to prepare for that, is just have a dedicated spokesperson that I'll interact with during the live stream. The actual requirements for what you're going to submit for your agent. So obviously you're going to develop it using reinforcement learning, which I'll get into a little bit more when we talk about Kessler itself, the game that you'll be playing. But these are some of the requirements that your developed agent must meet. So the reason why we call it XFC is explanations, or explainability. So your agents must have the ability to optionally output explanation strings every time step. When I say optionally, I mean that there needs to be some way for me to simply turn on or off the explanations from an interface. Now that can just be, it can just be an attribute that's set in your controller class, which we'll talk a bit more about that as well. I just need to be able to turn it on and off, so it's not always on, it's not always off. It must have the ability to log to a text file or similar. Just a human readable file, text file is fine. This way we can go back and audit your explanation outputs after the fact, not only in real time, but then we also want it to have the ability to be able to be printed in real time, either to console or just the Python console. The explanation formatting and the content is up to the teams. That is something we leave to you. The grading of the explanation outputs, this is part of the scoring for one of the prizes. I'll talk about the overall prizes for the competition in a little bit. But you will be graded on those explanations based on an XAI rubric that's been developed by us and Dr. Scott Dick at the University of Alberta. And so this goes into things like, do I, as the human, understand the explanations? Are they telling me relevant information? Do I trust the system based on what it's telling me? Or, would that explanation increase my trust if it explained itself properly? Things like that. Um, th we will make that rubric public. There may be some modifications between now and then, though. So once we make any of those modifications, I will allow the teams to see that. So besides explanations, we also would like you to make a custom ship sprite. I'll give you the details for this in a little bit, but basically you're going to make your own custom ship graphic that we can use. We can plop that right in and use it in the game. It makes it a little bit more fun, and it also helps it just be easier to distinguish the teams when we're watching them play the game live, because we will be watching your solutions play against other team solutions live in the game. So it's much easier to pick out which is which, and plus it's a lot of fun. There's also an associated prize with the custom sprites where it is a peer award. So all of the teams that submit sprites get to vote on all of the other sprites, and we do ranked choice voting. And I'll send out the request for the votes once we get all the ship sprites, and then there's an associated peer award. So there's also a prize for the best ship sprite. Some other requirements for your agents. We've gone over this. It's now in the rules. We've had some issues with, we'll say, enthusiastic solutions that found clever ways to play the game. But it's now explicit in that your agent must not modify the game. You cannot modify the operations that are happening within Kessler. You cannot modify the game state, which is the information that all of the ships are receiving from the game every time step. You also cannot modify the ships or the ship states or anything else within the game, or the input or output action spaces of the controllers for either yourself or someone else. If you do this, it will result in immediate disqualification. Um, you know, I think that speaks for itself. Only send the associated files with your controller. This is something that is in our development guide. I'll go ahead and say it now. You should check out the tutorial files and development guide that we have on the website. I'll go ahead and actually just pull up the website real quick. So here is the website for the competition, our GitHub website. And it's been updated, so it has the current info on it for both this competition, and I'll also mention the wiki competition, which is a separate but parallel competition that we're running. And here is on the main page, it has the link for registration for XFC. It also has this link for a zip file that has both tutorial files and also a getting started and development guides. This tells you a lot of information about how to get started with making specifically a genetic fuzzy based agent to play the Kessler game. It also includes some other things like the way you should format your directory where you're going to put your controller and its associated files. And so the reason I'm bringing this up is because when you submit your final controller, we only want your controller class, the files associated with that. And I do not want to receive, like I have in the past, multiple copies of Kessler where the Kessler directories itself were used for for development. So the tutorial files break that down. There's examples there, and they show you both how to structure it, and that also makes it easier on us for when we're integrating. It's not stated here, but it is stated in the rules on the website that I do prefer that teams store that. Well, this is honestly up to the teams, but you should be using version control and having a repository for your agent. This makes it much easier on you as the development team, but also on the organizers as well, because then it's also possible for us to go and grab your code if need be. And that way you can also hold like your final version in a separate branch. It makes it much easier to deal with different versions. Uh, the final presentations that I mentioned, I will give you a template and the required content for it soon. They won't be long, maybe 10 slides max, and generally we're targeting somewhere around a 5-minute duration for explaining what you did with your agent, both how you trained it, how you decided to do the explanations, things like that. Also what you learned, but again, this will be in the template. This will be a requirement this year to submit it in video form. You can talk with me about how to submit it. You can either go ahead and upload it to, if you have a way to host it, like on YouTube or something else, you can just send me a link, or we can figure out how to transfer the files. And if there are no issues with it, I'll upload it on the XFC YouTube channel. And these will be played before the competition. So the way the competition breakdown is, which I have on the next slide, is that I will go through an introduction and brief initial presentation about the competition and what everybody's done, both in the past and this year. And then I'll go through the student presentations. Then after the student presentations, we'll do the actual competition in Kessler. We do the same thing for the wiki competition. I'll go over some of the finer points about the differences between them as well, but we will be doing the same thing. So if you can sign up and submit your agents to both, and I highly encourage everybody to do so for both XFC and for wiki. But they are separate. They also have separate registrations on the website, and we will show the team presentations before XFC and before the wiki competition if time allows. That really just depends on the number of teams that have submitted. So the final competition day, this is a tentative schedule because we're trying to accommodate multiple different time zones. Typically, we normally have submissions from the West Coast of North America all the way to, we've had teams from Japan in the past, and we commonly have teams from Europe. So we're trying to really bridge a global audience with the time. And so it's unfortunately just going to be difficult to accommodate everybody at a reasonable time. So we're going to try to do around mid-morning or maybe late morning Eastern time. All the times I have here are the Eastern time zone. So we're going to start first with the student presentations, and I don't have it here, but I'm also going to have a presentation before this. So that usually takes about, I would say, 20 minutes. So I'll make sure to firm this up as we get closer, but I will start with that intro presentation. We'll then transition to the student presentations. And then the competition live stream will be after that. The live stream is also a bit up in the air because it's extremely dependent on the number of teams that submit and also the number of scenarios. I haven't finalized the scenarios that we will see during the competition. I do modify them every year because you can go and look at what the scenarios were that the previous teams had to play against. And so we want to make sure that we're testing your agents against things they haven't seen before. But regardless, it'll probably be, I expect, at least an hour, maybe closer to an hour and a half for the full competition. Typically, I try to keep the individual matchups, each matchup in the playoff bracket to around 5 minutes, maybe a bit longer, but I will tailor that such that we don't run too much over time. And then we will have closing statements right there with the preliminary results. We'll be seeing the progression of the bracket. Excuse me. We'll be seeing the progression of the bracket, so we will immediately see the results of the first through third places for the actual playoff itself. But then there are other awards that we will be judging and getting the results back for. And I have it stated here that that will happen no later. The notification of final results and prizes will happen no later than July 17th. I have travel right after the competition. So this just gives us ample time to be able to collect everything that we need from the judges for your explanations, as well as things like the peer reward and shoring up all of the results and getting all the data. Oops, this was out of order. I've already talked about the playoff, but it is a single elimination style playoff. Again, seeding is determined by that evaluation against a baseline agent. The scenarios I'll give you a bit more information about. They are chosen to elicit certain behaviors and performance from the agents. So we're going to put them in situations that are interesting, and so we want to see how they react and how they perform. The initial conditions for all the scenarios will either be such that each agent is either doesn't have an advantage based on their position, or we will run it twice and swap the locations to make sure that any initial condition that does confer an advantage is fair, and so we get to see it for both teams. This is just an example of a single elimination bracket, so it'll be in this format. This is a case where we have 19 teams, and so you can essentially see there are these play-in games, 16 versus 17, 15 versus 18, and 14 versus 19. And then we get into the rounds with everybody. So essentially everybody except for these 6 teams has a bye essentially in that round. You can think of them as like wild card or play-in games if you prefer. It really just depends on the number of teams that submit agents for us, and then we will construct it based on this formatting. We do also have a third place match. So not only do we have all of these matches, but the 4 teams that advance to the final 4, the 2 winners will advance to the final, and then the 2 losers in the final 4, they play an additional match to determine the third place, which there is a prize for as well. A bit more about the explainability portion. So, like I mentioned, it needs to explain its behavior by outputting English language strings. These both need to be logged and have the ability to be logged and the ability to be printed in real time for real-time evaluation. And we run these through dedicated scenarios to, again, elicit certain behaviors. These are ones where we really care about what your agent does, and we want to identify why it did what it did. And so that's the things that your explanations should encompass. Did I prioritize this large asteroid over here, or did I prioritize a very small asteroid for some reason? Those are the things that we're looking to see explanations about. The judging of this, they will be judged by a panel of human judges where we assess the quality and presentation of the explanations from your agent, and we score them based on a number of things that are in that rubric that I mentioned earlier. So a number of criteria based on the ease of understanding it, the sensibility of those actions, the quality of the explanations, and maybe I have innovation here, but really what that means is there's an aspect of this that is up to you and how you present those strings. You can, I highly recommend testing this on yourself, maybe against that rubric that we will send out as well. Is your agent telling you information that is valuable? Does it help you understand why it did what it did? And do you trust it more based on the explanations it's actually giving you? So those are the types of things that we care about for this portion of the competition. This is just an example of one of the scenarios that you might see for explanations. So consider a case where your ship starts in this position and you have 3 asteroids, 2 of which are stationary but somewhat close to you, and then you have another one that's further away but coming at you at a relatively high rate of speed. What do? Do you prioritize targeting this one? Do you prioritize moving away from the one that's coming towards you? Do you try to shoot the one that's coming towards you? These are the types of things that we're interested in understanding about your agent. So again, this is just an example. There will be several that you see. We do not give out the explanation scenarios beforehand. We do record the sessions of the agents going through the explanation scenarios once. and those are put up on the YouTube channel afterwards. This is essentially just so everybody can see that their agent actually went through and was giving the explanations. Um, but the judges use a combination of both the real-time outputs along with auditing after the fact. If there's questions on this, I'm happy to go a little bit more in depth, but that's the main takeaway. So switching back to the live stream information real quick. Again, this will be streamed live on almost definitely YouTube, and then maybe some other services like Twitch. We'll see. I will be doing some more testing to make sure that the live stream is set up properly. We do format it kind of like an esports event where I do the shoutcasting and then sometimes interact with the teams like I mentioned. And like always, the stream will be recorded and hosted on the XFC YouTube channel for viewing afterwards for anybody that can't join live. And reminder that this seminar also is going to be hosted on the YouTube channel afterwards. Prizes. So there will be prizes. We have monetary prizes every year. It hasn't been determined what they will be for this year, but there will be a certain amount that is reserved for the playoff prizes, and so these are there are different amounts for first, second, and third. Those will be determined once we have the monetary amounts for the total pool. But the scoring for the actual playoff itself is determined by hitting the number of asteroids hit during the total run through all scenarios. So for any given matchup, you will have both agents playing the game. Whichever agent scores the most asteroid hits throughout those scenarios will be the team with a higher score. We do have tiebreakers in case there is a tie in asteroids hit, and that first thing goes to accuracy and then to the number of deaths to break those ties. If we still have tiebreakers after that, we'll look at other metrics like evaluation time. The likelihood of this happening is fairly remote, but we will cover our bases. The explainability, the top 3 teams, as scored by the panel of human judges, will receive prizes for explanation quality. I don't have it on here. We do also give out a prize for the most innovative solution as well, and that'll be determined once we know the total prize pool as well. We also have the peer award based on the custom ship sprites, which I mentioned. You will vote for your favorite custom ship designs. You can't vote for yourself, but the top 3 again get prizes similar to the explanation prizes. In order to be considered for this prize, you must submit your team vote, and you also have to obviously submit a ship sprite. Okay, so that is most of the information on the competition itself and the time frame, the structure, and the high-level requirements for what your agent needs to do and to output. I am going to switch to talking about Kessler real quick, so we can get a bit more in depth on Kessler and how to actually make your agent. Real quick though, I'll stop for any potential questions we might have on the competition itself before moving on to Kessler. Okay, it sounds like no questions so far. So moving on to Kessler. Kessler, again, is open source. You can go to the repository located here. You can check out all of the code, including some examples. There are more in-depth examples in the tutorial files that we have on the website, though, so I highly recommend going and grabbing those. It's completely open source and under an Apache 2 license, so you can use it however you like. You can fork it and make changes. You can also go check out the different releases to see how it's changed. There have been a lot of modifications within the last year to make Kessler much faster, more efficient, and better for machine learning purposes. So there is also a compiled version now, and you can install it either on PyPy or going to the repo and grabbing it. It does currently require Python 3.10. That's due to some of the graphics options primarily. This may change in the future, but just know that the version of Python that you need in order to run Kessler does need to be Python 3.10, at least for now. So some of the overall structure for Kessler, the controller, this class, which there's a class in the game called Kessler controller. This is the class that determines all of the control actions for your ship. And so you will develop a child class of this class. And so you can inherit Kessler controller, and you just need to make sure that you have all the same required methods that are in the base class, the parent class of Kessler controller. So that includes primarily the actions method. This is the method that returns the actions to the environment from your controller. So the inputs for this is the ship state and the game state. The ship state is the state for all the ships. The game state is just what it sounds like. It's the state of the game. And so the game returns a bunch of information, which you can see down here, about the game, including all the asteroids that are in the game, all the ships, all the bullets, the mines, map size, time limit, things like that. And so this is all the information that you have available from the game in order to make decisions about how your agent should behave. The return from this function that goes back to the environment is a tuple of 2 floats and 2 booleans. These represent the turn rate, the acceleration, and whether to fire your primary weapon, which is basically a gun, or your secondary weapon, which are mines. And I'll get into mines in a second, but essentially they are a static mine that you can drop, and it stays in the position where you drop it and has a certain time limit before it explodes, it detonates, and destroys anything or hits anything within the blast radius, including other ships. Bullets, however, can only affect asteroids, so you cannot currently shoot any other ship that is in the game, but you can deploy mines, and those affect anybody caught within the blast radius. So let's talk a bit more about ships. You have access to a bunch of information about any ship that's in the game. That is what this is showing you right here, this property. So it includes information about position, velocity, speed, mass, radius, ID, what team it's on, the number of lives remaining, and whether it's respawning or not. And then you also have a bunch of information that is only accessible about your own ship. So no, you can't see this about anybody else's ship, but you can see it about your own ship. And this includes things like how many bullets you have left, how many mines you have left, whether you can deploy your mine, whether you can fire your weapon. That's basically because there are cooldown limiters on each of these things, which you can go see in the game code. And the Getting Started guide has some of that information as well as the documentation that's in the Kessler repo. So some more information about asteroids. This is all the information you have available for asteroids and bullets. So you have position, velocity, size, mass, radius, and then for bullets you have position, velocity, heading, and mass. There is momentum in Kessler as well, so when things are impacted by other things, it imparts momentum on them. And then you have information regarding the mines. And so this is just position, mass, fuse time, and remaining time. So fuse time is the total time it takes any mine to detonate. Remaining time is the remaining time before detonation. So you can also define scenarios in Kessler. You'll see this in the example and tutorial files. There's a class called scenario for scenarios, and what you have to do is define all of the asteroid and ship initial states, the bullet limits. There's a few other essentially settings for determining how the game will actually play. Um, then you instantiate the game. There's both the normal game and trainer environment. The trainer environment version of the game object just sets things such that they run more quickly for machine learning. You can also just do this manually by setting those settings however you like. Mainly it includes things like setting the FPS, turning the graphics off, etc. There's also a score class. This is based on teams, and your score objects hold a list of scores for each team based on ID. And it includes a couple different things used for calculating scoring. You can also modify this, and this is where you would do modifications for determining your reward signal or your fitness function, depending on your machine learning or reinforcement learning paradigm. If you're going to do something more in the vein of traditional reinforcement learning, where you need time step based reward, or you need reward as the simulation is running, or some small horizon, not just at the end of the game, which is what currently happens, then you will need to build that functionality. That's not automatically given, but you can build that based on the game state information that you're getting back to your controller. So you can still build out those same things for calculating your reward signal. It just won't be using the score class that we have here. You just have to do it manually. Yeah, so in case anybody didn't catch that, the score class, this is returned once the game ends. So this score object is returned with all that information once the game ends. And when I say game, this is a run through a particular scenario. So once you run through that scenario, the game terminates and returns this score object with all the information. You can see an example here of a scenario definition, or the information that you need for a scenario definition. So you'll have things like the name, which is just a string, the number of asteroids. This is an optional input, the number of asteroids. If you set that, it'll just randomly generate that number of asteroids, or you can dictate the actual asteroid states. And so obviously the number is just the length of that list, and then you define the positions, the velocities, the speeds, the initial angles that they're traveling at, etc. You can also define the initial conditions for the ship states, the map size, the time limit, the ammo limit multiplier, which, by the way, this refers to the amount of ammunition that you have for your primary weapon relative to the number of asteroids. So if you set this at 1, it will give you the number of bullets as the maximum number of possible asteroids that can exist, because the asteroids, when you hit them, they split into 3 children, and then once they're the smallest size, they go away. So it calculates how many asteroids could exist at any given time in the sim, and gives you that number of bullets to start the game. And then some other things like the stop if no ammo. Like, this is an optional flag for stopping. So do you want the scenario to just end if all the ships are out of ammunition? Things like that. You can see examples of this, though, in the tutorial files, and there's some other separate examples in the actual Kessler files for doing this. This is an example of one called test scenario, which this is one of the examples you'll see. This one is just defining 10 randomly generated asteroids, and it's defining 2 ships. So the ship states that you see here, the position, the angle they start at, the number of lives, and which team they're on. It is possible to have multiple ships per team. Just know that in the competition, there will only ever be 2 ships, and it will be you versus 1 opponent. So you'll always be on separate teams from your opponent in the competition. That doesn't mean you can do things with a teammate if you'd like, both for competition if that's useful, but also if you want to use it for another project, that's absolutely fine, and do something else. You can define your map size, your time limit, and those other conditions I just mentioned. There's a number of settings within Kessler as well. A lot of these have to do with things like the time set, the frequency that it runs at, or the FPS. Things like tracking performance, whether it prints out certain things, the graphics type, which there is a default graphics, which is based on the tkinter package, which I recommend just sticking with those. There is an Unreal graphics option, but it's a bit more involved and doesn't include all of the things that Kessler has added over the years, so it's a bit Spartan at the moment. So I recommend sticking with tkinter. That's also what the competition will be run in. Other things like time limit, etc. So you can play around with different game settings, but really this is just going to be for essentially setting how long or the characteristics of the game that you're running. You can then instantiate the game with your settings. You pass it the settings and the scenario, and you can instantiate this game object. Once you pass it, or sorry, you don't pass the scenario until you're actually running. There's a run method in the game class. And so when you want to actually run the game, you pass it a scenario and the controllers. This is just a list of all of the controller objects that it is going to use for all of these ships in your scenario. So in this test scenario, we had 2 ships, if you remember, and so we're going to pass it 2 controllers. In this case, we're just passing it a copy of the same controller, that test controller that we saw. Again, you can see all these in the examples, and you can architect yours the same way. Just know that the location matters. It's always based on the index location. So the first entry will be the controller being used for the ship number 1, and the other controller for ship number 2. You can also see after running the game, you get back the score and performance data, and you can access all of this. You can see how long it took to actually do the evaluation. In this case, we're running it with no graphics, so it tells you how long it took to run. You can see the stop reason. You can see how many asteroids you hit. You can see how many deaths, your accuracy, etc. So you can look at all these things, and when you go to build your own reward function or scoring function, these are the things that you will have access to, and you can go take a look at those in the score class as well. And the team class, you can see the things that are stored there for access for you to use. Again, you can use other things, especially if you're calculating something inside of the game loop itself. You can calculate whatever you need to based on the game state. So that is most of what you'll be doing for developing your agent in Kessler. I will have another Q&A session and maybe go through the development guide and tutorial files more in depth. They're pretty self-explanatory. Well, the development guide explains quite a bit about what to do and how to architect your agent and how to actually perform machine learning. It does use a genetic algorithm. The genetic algorithm it uses is called DEEP, D-E-A-P. It's a Python package that has a lot of good functionality and is somewhat simple to use. However, the fuzzy package that is being used is skFuzzy, which is quite slow. So I do recommend looking at other fuzzy packages. There is the requirement that your system employs fuzzy in some way, but that it's pretty open-ended on how you actually use it. We've had some people that hybridize neural nets or some other method along with fuzzy inference systems. We've had some teams that used fuzzy as their explanation layer. We've used some that use fuzzy directly for control and decision making. So it's really up to the teams. And like I mentioned, there is an award for most innovative solution that's also determined by the judges. So that's where a lot of that comes into play as well, is we're really looking to reward solutions that come up with innovative ways for both generating explanations, but also just creating high performance Kessler solutions. So I mentioned ship sprites and how you can make custom ones. So you can go take a look at the existing ones that are within the game. They're in this directory within the game. So source, Kessler game, graphics, images, and then there's a number of them. These are some of the default ones that you see on the right. You don't have to uh, use these. You can make a completely new one. Or you can use these as a template if you like. You can add text, logos, change colors, whatever. Just make sure you have permissions for any images or anything that could possibly be used in your ship sprite. Make sure you have the rights to use it. And then you can send us your custom sprite. And not only is there the peer award, but we'll use it in the competition, like I mentioned. We'll also add it to the website where you can see some examples of previous ship sprites there. Some requirements. I do have here 5 kilobytes. That's pretty strict. I would say it must be around 50 kilobytes or under. We don't want to go more than that. Um, I'll work with teams to make sure that the sizing's appropriate. Um, and also try to keep it to about a 1-to-1 aspect ratio. That's because the ships are essentially within a bubble where contact or a hit, quote unquote, is just determined by distance. So there's a radius around the ship, which you actually see when they're playing the game. You'll see it enclosed in a circle. So anything that gets within that distance is considered a hit. But what happens is it scales your ship automatically, and so if you give it something with a really big aspect ratio in either direction, it may look really extended and skinny, and you may not be able to make out detail. So try to keep it to about a 1-to-1 aspect ratio, just so it's easier to view. And that's about it. These are the general high-level requirements for both the competition and how to get started in Kessler. I will have another session soon, both for general Q&A, but also just more in depth on development. I highly recommend going through all of the examples that are both in the Kessler repo and taking a look at some of the recordings from previous years to see what Student Solutions did. Those are all in the XFC YouTube channel. You can find the YouTube channel. I'll just pull up the browser real quick. So you can just search for like XFuzzy Comp YouTube and you'll find this, the Fuzzy Competition. That's our channel with all of the recordings from both previous competitions. We've also given a lot of seminars in previous years on things like genetic algorithms, fuzzy logic, explainable AI, etc. So there's quite a bit of information here. I recommend going through. You can also see the agent explanation evaluations. I have the recording from last year's on here so you can see what students actually did for generating their explanations and some of the scenarios they were put through. You can also see those seminars, as I mentioned. There are some highlight videos and also, yeah, some other seminars from further back, especially on things like fuzzy. So good resources. Also check out the schedule and other information that's also on the website. I do want to touch on Wiki real quick. Wiki, which is the World Congress for Computational Intelligence, it is a IEEE conference that's held every even year. It includes IEEE's Fuzzy, Genetic Algorithm, and Neural Nets conference all in one. So we're holding another version of the competition there at the conference. You can submit to both. There's no extra requirements for the wiki competition as well. In fact, this one is only aimed at performance in the game. It does not take into account the explanation portion. The explanation is just for XFC. So please register for both if you'd like. There's no reason not to. And yeah, I highly encourage everybody to do that. And if anybody has specific questions about that, let me know. But the dates for both are the same, except for the competition date. The competition date for Wiki will be during the conference there, which I don't have the exact date right this second until the agenda is fully formed. But the agent submission date will be the same. So 10th of June for both. And with that, I'll take questions that we may have in the chat. I see that we have one question. Go ahead, Hugo. So that I'm repeating this to make sure the recording captures it. The question was if there is some other type of algorithm, for example, like a PID controller, uh, how how will the explanation, or does the explanation method need to account for things like that? Did I summarize that correctly? Yeah, so to give more detail for those listening, they expanded and said, so if there is an explanation layer and or a decision layer that switches, for instance, is deciding to switch to a PID controller for some reason, does it the PID actions need to be explained, or is it the switching mechanism? That is up to the teams. That is part of the explanation innovation portion where you will have the rubric for how your explanations will be graded. But that is something that you will need to decide if the actions being taken by a, PID, or let's just say a black box controller that is not immediately obvious how you would get explanations from it that are relatable to a human. um, yeah, then in that case, there needs to be some way to capture that explanation and include that in what's returned to the human, if that makes sense. Um, there are teams that have done things like that in the past where they're essentially putting fuzzy rule or some level of rules onto another system, like a PID for, say, example, aiming at an asteroid. Um, that is something that you can do, but again, that is up to the teams. If you think that your explanation needs to include the information for, let's say it's used for aiming, why you aimed at a particular location versus another, then that explanation would, I would say, need to be included in some way. Does that answer your question? Sure. Yeah, in fact, in the past, what we've seen for some solutions is um, there was a hybridized system that used essentially a convolutional neural net layer for constructing a heat map for determining where in the map was safe or maybe desirable to go to. And their explanation method included both natural language sentence outputs and also a representation of the heat map. So it would say, I'm going to this location because it represents a threat level of X, and their heat map would show a visualization of that as well. Good question. Yeah, if there are more questions about the explanation methods, please let me know. I highly recommend taking a look at what some of the teams have done in the past, including their recordings from last year's explanation outputs and their presentations. And let's see, yeah, those are both in the competition live stream and the separate explanation recording. Any other immediate questions? Okay. With that, we will close our current session on the competition and initial Q&A. I will have another session getting more into development soon. I haven't decided the date and time, but I will send out the invitation for the seminar, and we'll go through more Q&A and the development and tutorials. So if anybody has questions before then, please reach out to me. My emails, both of my email accounts are on the website. Sorry, only one is on the website currently. I'll add my other one. Oh, they are both on here. Okay. So at the bottom of the page, both of my accounts are on there. I recommend emailing both of them just because my email situation is complicated, I will say. So with that, we'll close today, and I'll make sure that this seminar is uploaded onto the YouTube channel. Thanks, everybody.